Hello, Advanced Algebra. Today is lesson 5.4, day 1, which is factoring review, and then we're going to add a different type of factoring to it. If you remember, factoring is reverse foiling, and when we do this, we always go ahead and look for the greatest common factor first. So right here, when I have x to the third x squared x, I have a greatest common factor x. And then when I divide everything by x, I get a remaining polynomial, which would be x squared minus 4x and then minus 12. But then I have to, before I finish, I have to determine, is this remaining polynomial factorable? Well, if I were to factor that, I'd have to find the numbers that multiply to give me negative 12 and then add up to, right, negative 4. What numbers multiply to give me negative 12? Let's say negative 6 and 2. And do those add up to negative 4? Yes. So this would completely factor as x times x minus 6 times x plus 2. Okay. Now the next one, right? 6, 32, and 10 all have a common factor of 2, right? And then I have x to the third x squared and x. Therefore, I can factor out a 2x from each term. If I divide each term by 2x, right, I would get 6 divided by 2 is 3. X to the third divided by x is x squared. Then I would get plus 16x and then plus 5. Now, here's the thing. If you remember, I have to check to see if this is factorable. Right? Now, this is a little different. When I go to factor that, 3x squared plus 16x plus 5. Remember, we did the x method. We have to find the numbers here that multiply to give us 3x squared, numbers here that multiply to give us 5, and then we check the cross products. All right, for instance, I know 3x and x will multiply to give me 3x squared. Then I'm going to try combinations of numbers that multiply to give me 5 over here. Say 5 and 1. When I cross multiply here, this gives me 5x. 3x times 1 is 3x. Does this add up to the middle term? No. So that combination does not work. So we're going to go ahead and try it a different way. Right? We're going to put the 1 here, the 5 here, and now 3x times 5 is 15x. 1 times x is 1x. Does that add up to 16x? Yes. Now we know that factors out to be 2x times. We go here, that's going to be 3x plus 1 times. The other factor is going to be x plus 5. Some of you guys might remember other methods from Algebra 1, but for right now, this is the method I'm going to show each time. Now the last one here, if I look, 5 is the greatest common factor for these terms. 5, and then I have x to the fifth and x to the third. I can take an x to the third out of each of them. I always take the lowest exponent if they all have it in common. 5 divided by 5 is 1. X to the fifth divided by x to the third is x squared minus 16. Then x to the third divided by x to the third is done. Now, this doesn't change. 5x to the third. But what you have to remember is this here is what we call a difference of two squares. You can think of it as one of two ways. What multiplies to give you negative 16 and adds up to 0, and you'll see that it'll be negative 4 and 4 gives you negative 16, and they also add up to 0. Or you can say it's a difference of two squares. What's the square root of x squared? X. What's the square root of 16? 4. And whenever we have a difference of two squares, you take the square roots and add them, and then you take the square roots and subtract them. And now this is completely factored. So the difference of squares is what we just talked about. That's this here. If I have a squared minus b squared, right? If you have two terms linked by subtraction, right? Take the square root of a squared, you get a. Take the square root of b squared, you get b. And right away, it factors out to be a plus b times a minus b. Now, sum of two squares, right? This here, if you have, say, a squared plus b squared, this here is not factorable. And the only reason is there's no way to cancel out that middle term. Now, we do have what we call cubes, right? And when we have difference, or we have a sum of cubes, right? We have a sum or we have a difference. So we have a to the third plus or minus b to the third. And whenever we have this, right, we call these the SOAP problems. And anytime you factor these, right, you're always going to have here the cube root of that first term, which would be a. Then you're going to take the cube root of that second term here. Now the sign that goes in here is what we call the same sign. Now this, whatever you get when you take the cube root, this is just going to be your a squared, right? Now this sign here is what we call the opposite sign. Then you're going to multiply the a and b together, and then you're going to square this side. So it'd be b squared, but this is what we call always positive or addition. We say it's so because if you look, same, opposite, always positive, right? So when we factor a sum or difference of cubes, right, you're going to follow the SOAP method. And we'll go through an example to show you. Now to know your perfect cubes, right? If I do 1 to the third, the perfect cube is 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. Okay. Now, let's look at a couple of examples here. Now, I notice this. I have two terms linked by addition. I cannot do a sum of two perfect squares, so I know I'm going to look for cubes here. What is the cube root of x to the third? That is x. What is the cube root of 8? That is 2. So what I have here is a sum of cubes, right? So remember, whatever the cube root is, that goes here. So the cube root of x to the third is x. Remember, this is the same sign. So what are we doing here? We're adding, so it's x plus. Then what is the cube root of 8? 2. Then here, we're going to take the cube root of x to the third, which is x, and we're going to square it. Remember, this sign is the opposite. So if this is addition, this becomes subtraction. Then we're going to take those two, these x and the 2, multiply them together. Then this last one is always addition, and it's 2 squared, which gives you 4. If you were to multiply this out, you would get what you started with, the x to the third plus 8. And this is how we factor a sum of two perfect cubes. Okay, let's do another example that's a little more difficult. Okay, so we take the cube root of x to the third, which is x, right? We take the cube root of 216, y to the third. Well, the cube root of 216 is 6. The cube root to the third is y. And we know right away we're just going to follow this algorithm in a way. You know, this is x, the same sign. So if this is subtraction, the same sign is minus. The cube root of 216 y to the third is 6y. Then you take that x, you square it. The opposite sign, so if this is minus, you know you're going to add. Multiply the x and 6y together, you get 6xy. And this last sign is always addition. So what do you get here? 6y to the second. 6 squared is 36, y squared. And this is what you get. Remember, right, that if you were to multiply this back out, you would get what you started with. All right, a couple more examples. When you look at 3, I notice -2 is a common factor, so I'm going to factor it out. I have x squared, so I'm going to do -2x to the second. When I divide by -2x squared, I end up with x to the third plus, it's going to be 125. Now I have to ask myself, is this here, right, a difference of 2 squares? No. What it is it ends up being a sum of 2 cubes. So what's the cube root of x to the third? X. What is the cube root of 125? Is 5. So I know right away I have my GCF here, -2x squared. Then when I factor my sum of 2 cubes, I say sum because this is addition. I take the cube root of x to the third, which is x. It's the same sign, so it's plus. The cube root of 125 is 5. I know this is that x squared. This sign is the opposite, so it's minus. Multiply the x and 5 together to get minus 5x. And then it's always positive. 5 squared is 25. You must have, when you go to factor this GCF must be part of your answer. All right, so keep that in mind. All right, a couple more here. When I go to factor this one, there's no GCF. But when I go to take the cube root of 8x to the third, I get 2x. When I go to take the cube root of 27y to the third, I get 3y. So right away, that's going to give me 2x, same sign, so it's plus 3y. Then 2x squared, that's going to give you 4x squared. The opposite sign is minus. 2x times 3y is going to give you 6xy. And then 3y squared is going to give you plus 9y squared. Remember, if this sign is plus, same, opposite, always plus. All right. Then the last one, the GCF here would be 3x to the third. And when I divide by 3x to the third, I end up getting times x squared minus 16. Right now, when I look at this, I have two terms linked by subtraction. The key is this a perfect cube or a perfect square? This is a perfect square, right? And if you have a difference of two squares, right, a squared minus b squared, you do a plus b, a minus b. So what's the square root of x squared? X. What's the square root of 16? 4. So this becomes 3x to the third times x plus 4 times x minus 4. And this is completely factored now. This will come in hand when we get to simplifying rational expressions. So factoring is very important to know. We'll go over this when I get back. So please make sure you attempt the lesson and the homework. All of the homework from all the other sections are uploaded on Canvas. So do the homework and check your answers.